Now, globally, there are a number of forces that are acting to transform the world at a pace like never before, and it's influencing engineering. I'm Marty Dunn. I'm the Dean of the College of Engineering at CU Denver. We've just completed a strategic plan that's in essence rebuilding our College of Engineering. This will be a new building that'll be the physical response to that new vision of engineering education. This new building's going to provide some fantastic resources to our students, and it's going to give them access to cutting-edge technologies like robotics, like 3D printing, like augmented and virtual reality. It's going to give them the ability and the space to collaborate.
My name's Sam Mills, and I'm a PhD student here at the University of Colorado, Denver. I'm working on a project that's been funded by the NFL to help improve football helmets. So our goal for this project is to make safer football helmets for football players. We are trying to improve these helmets by using this material that we invented here at CU Denver. We think that it could really improve the performance of helmets. And what I'm specifically doing is working on building a computer model for that material so we can test it virtually. So what really gets me excited about modeling this new material is while we think it will be really great to improve football helmets on all levels of football, we think there's a lot of different applications, spinal fusion devices, knee and hip replacements, and we think that this could really make an impact in those spaces as well. But if we prove that it'll work well on the outside of the body absorbing energy, we think that we can really show that it would perform well inside the body.
My name is Nikki Clark. I'm a PhD student / graduate research assistant, and my project is working on a clinical augmentation tool for children with complex CP. He's technically a robot and he looks like a bunny, so his name is Wabs. We found that these kids need hundreds of repetitions daily, and so we want something that can be a standalone augmentation tool to work with these children. I've always had a passion for robotics, and then I've also loved working with kids, and so getting to kind of marry the two and especially help kids who really need it it's just really great.
My name is Andrew Gross. I'm a Bachelor of Science Electrical Engineering student at the University of Colorado, Denver. And my senior design project is working with Team Hyperlinks to build a Hyperloop pod for the SpaceX Hyperloop competition. SpaceX hosts a competition out in LA every year where teams are invited to bring their pods and then race them against each other. In September of 2017, SpaceX announced that teams would have to power their own pods. So essentially, as soon as I got involved with this project, it went from build us a soapbox derby racer to build us a Prius. So not only do we have to physically build a lot of these components, but again, we have to actually get them working together. So I would say that's our biggest achievement as a team, and something that I feel like I've really pushed the team to do is to design a vehicle that we can actually execute on the design for.
What I think is really important is providing those educational opportunities that really are at the cutting edge and are going to prepare them to be leaders in this rapidly changing dynamic world.
We're trying to train a new workforce on how these new technologies can really change the way that we think about engineering. And if we have well-trained and well-educated students who graduate from here, I think they'll really be prepared for that.
So the future kind of is changing quite rapidly as technology is changing. It's actually changing how we need to think about engineers and the talents and the skills that engineers have. Broadly, our goals are to create a new model of engineering education to educate that engineer of the future. The building kind of will influence how we do that by enabling this new kind of collaborative teaching and learning and research. The environment that we teach in, that we do research in and so forth is inspirational and it's essential. It helps shape what we do. The ability to bring our students together where they can 24/7 have access to state-of-the-art technology to be able to engineer the future is really our dream.